Alright guys, welcome back. We're going to be solving another question from the fourth chapter of the Interior Mechanics by Meriam, and in this figure we have a VL puller which is designed to remove a V-belt pulley P from from its tight-fitting shaft S by tightening off the central screw, and if the pulley starts to slide off the shaft and the compression in the screw has reached 1.2 kilonewtons, so we have the force in the screw 1.2 and we know it's in compression. We need to calculate the magnitude of the force supported by each jaw at point A. So obviously our figure is symmetrical, so whatever we have for the right side, it will be the same for the left side. And also the adjusting screws at D support horizontal force and keep the side arm parallel with the central screw. So we know that these two are parallel. And as always, we need to dismantle the system to find the forces. And first of all, we're going to start with this part where we have the force that is on a screw applying it here. And we're going to have two forces in here. We can call them, so let's just call this one 1.2 kilonewton that we have. And we can call the other one maybe B, because that's going to be common in this member and the one that we're going to analyze after this. So we are in equilibrium, sum of all forces in x equals 0, same for y, and we're going to have our moment equation. As I mentioned, we have the symmetry of the figure in here, so the two forces that we have in here in these two force members, it's going to be the same. So basically, as long as we can find this angle here, we can call it alpha, which is same as this angle. We should be able to find the force being here. So let's see how we can find alpha. So if we just try to find the tangent of alpha, we're going to need information about this right triangle where, you know, this side is 60 millimeter and the other one is also 60. That shows this is half of this square, so the angle would be 45 degrees. And if we just do sum of all forces in y equals 0, we're going to have 1.2 minus the two forces of B that we have times cosine of 45 degrees equals 0, and our B would be basically 1.2 divided by 2 cosine of 45 degrees. Let's see what we get. So basically 0.6 divided by cosine of 45 degrees. Make sure to set your calculator to degrees. So 0.849 kilonewtons. Or if we just want to write it as Newton, we can do 848.5 newtons. All right, now that we have this force, we can move on to another member. We're going to go with this joint here in order to find the force at A. So we're going to consider two forces for now for A, AX, AY. And obviously we have the same force B in the opposite direction applying in here, B, and also we have the horizontal force D that the question is saying. Let's just consider that. And we're going to start with our moment equation since we have the most unknowns at A. So we're going to find the moment about A. And let's see what we have. So we need to resolve the force B, Bx, By, because both components are going to make moments. So we're going to have the moment of D, which is a clockwise moment. So negative D times the vertical distance from A to the line of action, which is basically this distance. So 90 plus 60, 150. We're going to have the moment of Bx and By. So this is our Bx and this will be our By. Both of them are counterclockwise. So positive plus By is going to be B. We have the same angle, 45 degrees, and the value for sine and cosine is the same, so it really doesn't matter. You write down sine or cosine. So the sine of, if we go with this angle, b sine would be the vertical component, and the distance here is going to be 15. And b cosine of 45, that's going to give us the horizontal one. Again, counterclockwise, positive times 90 equals 0, and this is going to give us d. So our b is basically 848.5 times sine of 45 times, I'm just going to factor this because, as I said, it's the same value for sine and cosine. So 90 plus 15, 105, and 150 is going to be in our denominator. Something wrong with this is going to be 105. So that's going to give us 419.99 newtons for D. And again, one thing I forgot to mention was the direction of the force at the first member here, and why we did go with upward, and that's because the member is in compression. So the screw is in compression, so it's trying to push this bar to the up. So that's why I consider upward force, and as a result, the B has to be in the opposite direction. And we need to keep in mind that at the beginning, because that's gonna dictate the direction of the B in the second member, so we need that information. So now that we have D, we just have to do sum of all forces in X and Y in order to find the components at A. So AX, we have D, which is 419.99, and we also have BX negative minus B cosine of 45, again equals 0 because of equilibrium. So our B was 848.5 times sine cosine of 45 minus 419.99. I missed. So our AX is going to be 179.99 newtons. That's our AX. And last one, sum of all forces in Y equals 0. We're going to have AY and the Y component of B, which is upward, so plus B, this time sine of 45 degrees equals 0. So first of all, our AY would be negative, so I'm just going to remove this part, the rest is the same. That's going to be 599.98 newtons, and the negative sign shows that the AY is actually downward. And last, we just have to find the magnitude, which is going to be the square root of AX squared plus AY squared. So 179.99 squared plus 599.98 squared, and that's going to be 626.4 newtons. And the final answer for this question. Everything was clear. Let me know if you guys have any questions. You guys take care. See you in the next video. Have a good one.